Welcome back to BrewFix, where coffee meets craftsmanship. And today we're diving into a quiet conflict happening inside every espresso setup. A conflict most people never see, but every technician eventually discovers. Espresso machines and water chemistry are constantly negotiating with each other, and sometimes they're outright fighting. Imagine designing a precision engine that expects clean, balanced fuel, but instead it receives a mixture that changes composition every day. That's what your espresso machine experiences when water hardness, alkalinity, and mineral ratios fluctuate. Because boilers are engineered to transfer heat efficiently through metal surfaces, yet when water contains elevated carbonate hardness, calcium and magnesium precipitate under heat, forming scale that behaves like insulation inside the boiler, coating heating elements, narrowing internal passages, slowing thermal response, and forcing the machine to work harder just to maintain the same brew. Temperature. It's like putting a winter jacket around your heating element and expecting it to react instantly. Over time, heat recovery slows, temperature stability drifts, and baristas begin chasing grind settings and shot times without realizing the machine's thermal efficiency has silently degraded. Now on the opposite extreme, many users install aggressive filtration or reverse osmosis systems believing purer is better. But when minerals are stripped too aggressively and not properly reintroduced, the water becomes chemically unstable, lower in buffering capacity, sometimes slightly corrosive, and incapable of supporting optimal extraction chemistry, meaning the machine may stay cleaner, but the espresso tastes hollow, sharp, or structurally weak. This is where the tension becomes fascinating. The same minerals that build scale also contribute to flavor extraction, particularly magnesium, which enhances sweetness and clarity, and calcium, which influences body and structure. So, when you eliminate them entirely to protect hardware, you unintentionally reduce the chemical tools necessary for dissolving complex flavor compounds from the coffee puck. Espresso machines are designed with assumptions. Assumptions about flow resistance, thermal conductivity, and material compatibility. Yet water chemistry determines how those assumptions play out in reality. Because bicarbonates buffer acidity, but also accelerate scale formation, sulfates remain dissolved but influence taste, and mineral ratios determine whether heat transfer remains efficient or gradually deteriorates. Think of it like a finely tuned orchestra where the machine is the conductor and water is the ensemble. If one section plays too loudly or disappears entirely, harmony collapses. Technicians see this over time when boilers show uneven scale layers, when solenoid valves clog prematurely, when pressure stability fluctuates due to narrowing channels, or when corrosion appears in systems running ultra-soft, improperly conditioned water. Even pressure gauges can lie subtly as internal restrictions alter real flow dynamics. The machine fights back in its own way, overheating, cycling more aggressively, requiring descaling, replacing gaskets more frequently. But the root cause is often not mechanical failure, it's chemical imbalance. What makes this battle particularly deceptive is that flavor and longevity are pulled in opposite directions. Because harder water improves extraction. Strength yet shortens component lifespan, while softer water preserves metal surfaces but can weaken extraction chemistry and reduce sensory depth. The true professional mindset is not to choose sides, but to engineer balance, using controlled filtration that reduces scale-forming carbonates while maintaining sufficient mineral content for extraction stability, regularly testing hardness and alkalinity, and understanding that descaling is not just cleaning, but restoring thermal conductivity and resetting the system's original engineering assumptions. Once you understand that every espresso machine is in a continuous chemical relationship with the water passing through it, you stop treating maintenance as a reaction and start treating water composition as system design, because the machine is not broken when it accumulates scale. It is responding predictably to chemistry. The real mastery lies in aligning engineering with mineral balance so that heat transfer remains efficient, Pressure curves stay stable, flavor extraction remains structured, and component lifespan extends rather than contracts. At BrewFix, we approach espresso machines like mechanical ecosystems rather than appliances. And when you learn to control water chemistry instead of letting it fight your equipment, you move from constant repair to intelligent prevention, protecting both your machine and your cup, keeping systems stable, flavors balanced, and mornings caffeinated with precision rather than frustration.